Math Blast 8. I can understand multiplication comparisons. 12 equals 6 times 2 is the same as saying 12 is 6 times as many as 2. Blank times as many as 3 is 18. Well, I know 6 groups of 3 is 18. So we'll say 6 times as many as 3 is 18 means that 3 times as many as 6 is 18. I can round to the nearest specified whole number. Round 547,651 to the nearest 10,000. Show your work. Well, I'm going to use a vertical number line to do my rounding here. It's important we know what place value we're rounding to. So in the directions, it said round to the nearest 10,000. So I'm going to ask myself, if 10,000s is my greatest unit, how many total 10,000s make up my number now? So I'll go from the left all the way to the 10,000s place, and I have 54 10,000s that make up my number. And in standard form, that's equal to 54 ending in the 10,000s place would be zeros then in the thousands, hundreds, tens, and ones. So 540,000. Now, the bottom number on the number line is 54 10,000s. What is one more 10,000? That would be 55 10,000s. That's what goes at the top of my number line. That is equal to 550,000. Now I want to determine the midpoint, the number that is right between 540,000 and 550,000. The midpoint is always going to be what's at the bottom of the number line here. So 54 10,000s and 5 of the next unit. So 5,000s. 54 10,000s and 5,000s. So that's equal to 545,000. Now I want to place my number, 547,651, on the number line. I'm going to place it right about here. 547,651 is above the midpoint, so it's going to round up to 550,000. Keep in mind when we're rounding, if our given number is at or above the midpoint, it rounds up. If it's below the midpoint, it rounds down. I can solve word problems involving metric measurement. The oranges Keaton bought weighed 1 kilogram, 920 grams. His blueberries weighed 1,380 grams less than the oranges. How much did the oranges and blueberries weigh together? For this problem, I'm going to draw some tape diagrams. So recognizing that Keaton's oranges are here, and they tell us that his oranges weighed 1 kilogram, 920 grams. So 1 kilogram, 920 grams. Now I know that we could say that is the same thing as 1,920 grams. Because 1 kilogram is equal to 1,000 grams. Now, his blueberries weighed 1,300 grams less than the oranges. So we have 1,380 grams less than his oranges. So that means the blueberries will be this portion of the tape. And we say that here's 1,380 grams less. So we want to know, well, then how much is that? So I'm going to take the weight of the oranges, 1,920 grams, and I'm going to subtract 1,380 grams. And that will tell me what the blueberries weigh. We'll keep our units in grams. 0. In the tens place, I have 2 and I'm taking 8 away. So I'm going to go over to the hundreds. I'll borrow 1, leaving 8 hundreds there. The one that I'm going to borrow or regroup here is going to turn into 10 tens. With the 2 that's already there makes that 12 tens. So now I have 12 tens minus 8 tens, which is 4 tens. I have 8 hundreds minus 3 hundreds, which is 5 hundreds. And my thousands, 1,000 minus 1,000 is no thousands left. So my blueberries are going to weigh 540 grams. Now, that's not the answer to the question yet. The question was, how much do the oranges and blueberries weigh together? So now I want to put these weights together. 1,920 grams for the oranges and 540 grams for the blueberries. And I'm going to add them. So we'll still have grams as our unit, no ones, 6 tens, 14 hundreds. We'll leave 4, bundle 10 of those hundreds and make 1,000. 1,000 and 1,000 is 2,000. So we can make a statement here. Keaton's oranges and blueberries weigh 2,460 grams together. On the back side, I can determine the perimeter and area of a rectangle. Determine the perimeter and area of the rectangle below. So here, the perimeter, there's this key word rim. That means I'm going to start at one point and work my way all the way around the rim of the figure. When I'm finding the perimeter, I'm looking for the distance around the figure. Now for a rectangle, we know opposite sides are equal. So this side is going to be 7 centimeters, equal to this bottom side here. And this right side is going to be 3 centimeters, equal to the left side here. So now, again, to find the perimeter, I'm going to work my way all the way around the rim. 7 centimeters plus 3 centimeters plus 7 centimeters plus 3 centimeters. So I'll write my expression here. And I know that that then is equal to 20 centimeters. All right, and let me make sure we can see my 2 there, 20 centimeters. And the area now. For the area, we're looking for the square units that make up this two-dimensional figure. We learned back in 3rd grade that we could count the square units inside of the two-dimensional figure when they're given to us there. Or I could draw those square units here because I know that the side is 3 centimeters, so that would be like 3 rows. And my top side here is 7 centimeters, so that would be like 7 columns. And I could count all the squares that make up that figure. But then we also learned that there's a shortcut to that. I don't have to count all the squares when I know that 3 groups of 7 is 21. The length times the width is going to give me the area. So I have 3 centimeters times 7 centimeters, which is going to be equal to 21 square centimeters. I can identify and construct parallel, perpendicular lines, line segments, and rays. Identify the ray below. So a ray has an endpoint and then continues on in one direction to infinity. So this point C, continuing on here to the side where point D is my ray. So I'm going to draw the ray symbol and below that write CD. And the letters have to be in that order because we need the first letter to be the endpoint. And then we move in the direction to the arrow. Draw ray ST parallel to line EF. So my ray ST, again, the point has to be the first letter S, and I'm going to move in the direction to the arrow. So we'll call this T. Parallel means they're never going to touch no matter how far extended. So my line EF, I never want to touch ST. And a line has arrows at both ends. It's going to continue to extend in both directions. So my points could be called E, F in this order, or I could have switched and put F first and then E. And the reason I can do that is because both ends are the same. Both ends have arrows. Now I want to draw line segment AB perpendicular to line PQ. So a line segment is a part of a line. It has endpoints at both ends. So I'm going to draw my line segment. And in this case, I'm choosing to draw my line segment vertical. Doesn't matter which way we want to draw it. But I'm going to call this A and B. And again, because both ends have points, I could flip those letters if I wanted to. Perpendicular means to intersect at a special point that creates right angles. So we're going to intersect here. That's creating right angles. And it needs to be line. So we're going to have arrows at both ends. PQ. And again, since the ends are the same, I can put PQ in the order that I have it here, or I could flip those letters. Now line segment AB is perpendicular to line PQ. That's all for today, math friends.